Hi guys, alright, we are in Unit 2. We have accomplished Unit 1, so now starting Unit 2, Day 1. And we have one learning target today, and is to write quadratic functions in standard form. I'm going to highlight that standard form. Standard form is really vertex form from now on, okay? And then we're going to talk about the important characteristics of that. So like the vertex, the intercepts. So let's now look at quadratic functions. When you're going to be seeing the instructions of what is a quadratic function or get in that form, it's our traditional ax squared plus bx plus c. Now our axes of symmetry, if we go by hand, that's when opposite b over 2a. It's like the beginning of the quadratic formula. Our vertex is having that x value from the axis of symmetry and plugging it in to the function to figure out what is the y value. And then our x-intercepts, let's remember, x-intercepts, there is a number in the x spot and a 0 in the y spot, okay? There can possibly be 0, 1, or 2 x-intercepts, okay? And then we find these by solving, by factoring, by graphing. So I am going to let's just do a nice sketch out and then label the important information so we remember. Let's just do those as my axes. I'm going to make mine open down. So that will be my vertex. I'm going to cut it down the middle. That's my axes of symmetry, AOS to abbreviate. Remember, that's always x equals the number. Then we have our x-intercepts. And then our y-intercept. All right. So that's just the quadratic function, right? And now we're going to talk about the standard form, so aka vertex form. So let's write that guy out. Vertex form, f of x is equal to a parentheses x minus h squared plus k. So our axis of symmetry is the same thing as x equals h, though. Now our vertex is h comma k, so the opposite of the h. And then it's opening up when the a value is greater than 0, right? So not negative. And it's opening down when it's less than 0, so negative value. All right. So let's jump into some examples on. Example 1, write the standard form of f of x function, okay? Then find the x-intercepts, the y-intercepts, sketch the parabola, and state the domain and range. Okay, guys, for us to actually get from this, regular quadratic function form, right, and get it into standard form, so above this, I'm going to make myself a note. Standard form, I'm thinking vertex. We have to complete the square. So what do? I move everything that doesn't have a variable attached to it to the opposite side. So I have x squared plus 4x plus something equals, I would have added the 1 over, so there's that positive 1 plus something, okay? I automatically draw these in, and I automatically have them as pluses because it is always going to be a positive number. Make sure you keep it even, 1 on the left, 1 on the right. So how do I get that middle guy? I need to take the middle one, the 4. I divide it by 2, and then I square that answer. So 4, whatever I add to the left, I make sure I add it to the right to keep it even. The next step is getting into vertex form. So x, when you divided the pink term by 2, that's what goes here. Squared equals 5. I cleaned up the right side. Vertex form, right? The standard form, it's always set equal to 0. So I'm going to now, last step, subtract that 5 over to get f of x is equal to x plus 2 squared minus 5. Alright, so step 1, we got it. Step 2 now says we need to find the intercepts. So for the, let's go x-intercepts, I'm going to plug in a 0 in, and I'm going to solve for the x. Add the 5 over, take the square root on both sides, subtract the 2, please make sure you write the whole number, not the radical number, first. It's more of a mature answer, okay? So we have our 2 answers for this guy. Now we have to find our y-intercept. So here's the cool thing about the y-intercept. Yes, you can plug any 0 in for the x and figure out what the y is, but the original problem, quadratic function form, tells you what the y-intercept is, guys. It is always the c value, the term that doesn't have a variable attached to it. So in this one, our y-intercept is 0, negative 1 because of that last guy. So it's now to sketch. Step 4. Again, we are sketching this out. 0, negative 1, there should be a dot. I'm going to put in my vertex. Vertex should be at negative 2, negative 5. It's opening up. Kind of, if you want, you can approximate where the x-intercepts are for now. Okay. Domain stays the same. All real numbers, so it's an interval notation, please. And our range, bottom to top, it is hitting at negative 5, and it's opening up, so a positive infinity. Make sure you have a bracket on that guy. Alrighty. Example 2. Write in standard form, so vertex form. Then find the minimum, maximum value, and state the domain and range. So first step, getting into the right form. So we need to complete the square. But I realized something different about here. For you to complete the square, the a term has to be a 1. The previous one already was a 1. So first, I'm just going to move that 3 over, and I get this negative 4x squared minus 4x is equal to negative 3. I'm going to take away that negative 4. So then I have x squared plus an x. Be careful because you took out a negative, right? Plus something is equal to negative 3 plus something. So I'm going to take the middle term, divide it by 2, square it, 1/4. Whatever I do to the left, I do to the right. So add 1/4. But then I'm like, wait a minute, did I actually add 1/4 then? Common mistake, guys, here. That's why I did it. 1/4 is incorrect, actually. Because what did I actually add to the left side? Well, if I distribute that in, negative 4 times 1/4, that's actually a negative 1 that got added to the left side. So it's a negative 1 that got added. All right, last step. F of x, keep the outside -4. Now we have x, take the yellow term divided by 2, that doesn't change, so that's 1/2. If I cleaned up the right side, that would have been a -4, and then inverse operation, moving it to the other side, was a +4. So we have our h and our k. Remember, it's a -h, opposite. Let's go to our next part. We have to find the vertex. So that's why we get in this form. So our vertex is a -1/2, +4. And then I have to figure out, is this a max or a min? This is a max. You should know that because the a term is negative. So the a is less than 0, which means it's opening down, which means it has a max. Good. And then that takes us into step 3, domain and range. Domain stays the same, -infinity to +infinity. My range is opening down, so I take the -infinity and it's going to go to the highest point, which is the vertex, for bracket, because it's actually hitting at that point. Okay. All right. 3. Write the standard form of the quadratic with vertex 1, 2 passes also through 3, -6. So y equals, let's just write out the original form, x minus h squared plus k. And our goal is to always put in numbers for the h, the k, and the a. X and y stays the same. So I go in, and I'm going to take my vertex. So it was a 1, okay, and then it was a 2. Great. Well, my issue is I need an a. And they give me this random point of 3, -6. So what am I going to do to figure out a? I have too many unknowns. Well, why not use that 3 and plug it in for the x spot, and use that -6 and plug it into the y spot? So -6a, 3 minus 1 squared plus 2. Cleaning this up a little bit. 3 minus 1, 2 squared, 4a plus 2. Do some inverse operation here. Subtract the 2, so -8. Divide by 4. I got a to be a -2. Perfect. You have an a, and you were given an h and a k. So y equals -2 x minus 1 squared plus 2. Or as a function, I can write it as f of x, and then everything else would be exactly the same. Perfect. All right, that takes us into example 4, guys, some actual word problems here. A poster is 10 inches longer than its width. Write a function that models its area in terms of width. We're going to take this apart, okay? So we have a poster. We have our length, we have our width. Okay. The poster is 10 inches longer than its width. I didn't say anything that the width is 5 inches or whatever. So I'm comparing the length, and I'm saying that it's 10 inches longer than the width. So we translate that. Length is 10 inches longer than the width. Write a function that models the area. At that point, I would stop. When I say write a function that models its blank, you stop there. So area, at that point, I go down and I actually write the function that represents area, length times width. Okay. At the end, it says, what do I want to plug into that? I want everything into that purple equation of area with width. That means I need to get rid of the length. So plugging it in now, the length inside. So area equals, this is the new length. Copied the second W still from the original width. Distribute the W in. And there we have a function that models the area, right? It's an A equals, but everything is with respect to width. Okay, so again, hint, read what I want it to model, write down that equation, so we did the area, then look at in terms of what, okay? Example 5 then. Same thing, just changing up my shape. So write a model to express the circumference. I stop. Circumference goes with the circle, right? Alright, so circumference equals 2 pi r. Yes, we need to know this. Here's a little advice, guys. Curious if anyone's going to know this in our Zoom session. Should probably throw some extra points to this. If you don't remember circumference, you can sing this fabulous song, Twinkle, Twinkle, Little Star, the circumference of a circle is 2 pi r. Okay, nice way to remember that. So I have that down, and then I'm looking at the second part, and I'm saying in terms of what? In area now. So that's not just like width, right? I'm literally needing to take now the area equation. So area of a circle is pi r squared. And I need to take that guy and plug it into the circumference. So the issue is, where do I plug it in? You want to know what the circumference is, so the only spot to plug in is r. But we have a, so I'm not plugging in a. That means I need to solve the area equation with respect to r. I want it as r equals. I want to isolate the r. So we need to start solving for r. First thing, get rid of pi. Remember, pi is a number. Yeah, it's irrational, but it's a number, okay? We want to isolate. Some people are like, wait, so we solve for pi. No, there's nothing to solve for pi. We know what pi is, right? So we're solving for r. Take the square root. And then what do we get here? R equals plus or minus, because you took the square root. So you have to make sure you have both sides. Now, you have to also make sure, does it actually make sense to have a radius that is negative? No, I've never heard of that. So we are only strictly going to take the positive one, okay? Let's rationalize this. Multiply top and bottom by the square root of pi. So this is equivalent to a pi over pi, okay? If you need to show that step off of multiplying top and bottom by pi, make sure you do that, okay? Last but not least, we need to just plug in r now. So I go back to my circumference, 2 pi. I plug in what r represents, so square root of a pi over pi. Clean up. If I'm capable, I am in this one. I have a pi in the top and in the bottom. So I have the circumference is equal to 2 square roots a pi. That is our final answer. I know it looks like we just made it super crazy, but that is it. So this is the expressing the circumference of the circle in terms of the area. Okay. Challenge. Maybe try reversing it. So express the area of a circle in terms of circumference. Does it change? Okay. All right. Example 6, guys. Put a star around this one. This is a very nice one. There tends to be some questions always over this one, so I'm going to take it a little slow. You have a rectangular region is bounded by the x and the y, which is just a curve then. Express the area of the rectangle in terms of x, the horizontal distance from the origin. Okay, That was a lot to take in. Kochanie, możesz wejść. Okay, shh. I'm gonna keep going. All right, so let's kind of draw this out. And we're just gonna sketch it. Let's see if we can answer this. So you have this weird curve. And if you graph this into your calculator, you are going to notice, and some of you guys maybe already know, that it is like half of a circle. Best of my ability. And underneath this curve, there's a rectangle, and it doesn't pass the x-axis. Okay, so I'm just going to draw in a rectangle. And that's my rectangle. Express the area of the rectangle in terms of x. Okay, so I want the area of a rectangle. So we know area of a rectangle is length times width. Then I looked at the second part in terms of what? It wants only x's. Well, I'm like, wait a minute, there's not even any x. What are you talking about? Right? So now I'm going to ask you this question. You need to figure out, what is this length? That's our length, right? We got to figure out what that is. Right now, if you're thinking it's 4, I'm going to say it's not 4. And I drew it like that. That would be kind of close to like the 2 marks. But I just drew that in, okay? I could have absolutely drawn in this triangle or this rectangle. That's still a rectangle that's bounded by the curve and the x-axis. There's nothing different there, right? So now I know whatever this side is, let's just say that's x, from here to here, the other side has to be the same length. Clearly not drawn to scale, guys, but it has to be the same length. So that total length is 2x, right? There's 2 of them. So I'm going to go 2x into the length spot. Now I'm having an issue because here's my width. Well, what the heck is the width? Am I estimating and saying it's 2 because that's where I hit it when I sketched it? I can't. So, background knowledge. Beautiful Algebra 1 teacher decided to draw in a linear function. Okay? No tick marks on the graph, nothing like that. And she says, well, give me a coordinate when x is equal to 1, what is the y? You'd say, well, I don't know what it is. Like, you can guess, but I want exact answers. What does your teacher have to give you? Your teacher needs to give you the actual equation. What are you going to do? You're going to take that 1, you're going to plug it in to the equation, and you're going to figure out 1 plus 4 is 5. Great. You are going to do exactly the same thing here. Whatever x value we're going to plug in, it's going to spit out the y value. But what are you going to plug it in? You're going to plug it in to the actual curve that I gave you guys. I already gave you what is y. That is our width. So the square root of 9 minus x squared. This is equal to our area. So that means any point on here, if I decided to pick this point, its coordinate is some x value, its y value is whenever I plug in that x, whatever it would spit out. And then it didn't say to solve or anything, right? So it's just said to express the area, so that would be our final answer, expressing the area. And all I have are x's, so perfect. All right, guys. This is the end of day 1 notes. Make sure if you have to rewatch it, look at the written notes. look at some problems. Make sure you come to class asking questions and advocating, okay? All right, keep up the great work.